Welcome to the G-Lab in outer space. Today we're going to take a look at the seasons as we see it from space with this program called Sun, Earth, and Moon. And imagine this. It's the Sun, the Earth, and the Moon. What a creative name. And the cool thing about this program is that you can take a look at, so like by pressing F5, for instance, you can see the orbit of the Earth around the Sun. By pressing F7, you can see the orbit of the Moon around the Earth. What a deal. And F4 gives you some guides on the actual Earth, the equator, the poles, and what we can do is take a look at how this works as we orbit around the Sun. So I'm going to hit E to lock it on the Earth, and we can speed up the rotation of the Earth. The spinning is the rotation. And that orange pole sticking out there is coming right out of Oregon. So it gives us a good reference point. And by pressing the number keys, you can speed up or slow down the Earth to various speeds and see how the Earth moves as it orbits around the Sun. So as we're moving along here day after day, there's one day, another day. Each time the Earth rotates, that's about 24 hours. And so we're going to cruise right around here. Well, we'll go weeks or maybe a few months at a time here pretty quickly, and take a look and figure out if we can see which season is which based on where we are standing. All right, so using the A and the Z for accelerating forward or backward, and then just using the arrow keys to steer with, we can cruise around to various places and take a look at what's going on. I'm going to go ahead and turn off the orbit line. You can see that the Sun must be over here to the left, and the bright side of the Earth, half of the Earth is lit up at any time, is right over here. And you can see now that Oregon is about to go into darkness. So there's sunset, and it is now dark in Oregon. And if you watch a place like Alaska, for instance, which is right there, let's keep an eye on this one here. You can see Alaska goes into darkness right there, and it gets just barely dark, and it's already starting to get light again. And then in terms of how long the night was, that was pretty short. Alaska is now back in the daylight, and it's going to be day for a long time. In fact, that's one of the easiest ways to tell which season this is, as the Earth is tilting the north hemisphere, the northern hemisphere above the equator. The North Pole here is tilting towards the Sun, and so you end up with these long days in the northern hemisphere. Look at this, it's still daytime in Alaska. Here comes Alaska. And it's finally starting to become evening now. And it's late in the evening, but it's now actually just the sun's going down. The sun just went down, it's dark, it's nighttime, and now the sun's already coming back up. So you have these long days and short nights. And in fact, if you look at the actual North Pole itself, it actually never goes into darkness on this date. So this must be somewhere around June 21st, which is the summer solstice. We have there, it's the easiest way to figure out which season it is, just to look at the North Pole. And if it's in constant daylight, if it's tilted toward the Sun, that's summer. Now, of course, the very opposite thing is happening on the other half of the Earth. And if we fly down here below the Earth a little way and look back up at it, we can see that the South Pole is in constant darkness. Look at that. So as the Earth goes around, we'll speed it up a little bit. Day after day after day after day, the Earth is in constant, or the South Pole, Antarctica, is in constant darkness. And in fact, if you look at a location like, say, the southern tip of South America, say the southern tip of Chile, there it is right there. Dark, dark, dark. It is dark for a long time, and only there does it become light again and it's dark again. So there we have short days in South America, in Australia, in anywhere south of the equator, New Zealand, and definitely in Antarctica. It is dark much of the day, and so this must obviously be the season of winter. Now, of course, we can speed ahead and take us a few months further into the orbit of the Earth. And so let's go ahead and turn this guy back on. We're kind of way down here, but we're going to speed things up. All right, so we're cruising around the Sun here. How about even faster? Woohoo! You can see the Moon going around. The Moon goes around the Earth about once a month, about every 28, 29 days. And as we come around, we should be able to find a season when the Earth's in a little different position. How about right about there? All right, so let's cruise in and take a look at what we've got going here. You can see now that the South Pole is in constant daylight. So this is obviously a very different season. South Pole is in constant daylight, and it must be summer for the southern hemisphere. And in the northern hemisphere, let's take a look at the North Pole. The North Pole is actually in constant, where'd you go? North Pole is actually in constant darkness now, which means that this is definitely winter up here in the northern hemisphere. And actually, if you watch for Alaska, let's see if we can find it here. Here comes Oregon, and here is Alaska. Was right there. Oh, okay, that was it. Not a whole lot of daylight in Alaska. Let's see if we can see that one more time from a little different angle. Here's Alaska right there, and that was it. Daytime lasted only a couple hours, really. Still dark, still dark, still dark, still dark, still dark, and finally comes daytime, and it's dark again. So this must be the season of winter in the northern hemisphere. This would be representing, for instance, the winter solstice on December 21st or so. All right, so what does this look like from, what does this look like actually from the Earth's surface? Well, here we are at the North Pole. And at the North Pole, of course, every direction you look is south. You can see that it's all south. And the North Pole sits on top of the Arctic Ocean, so it's actually just a bunch of sea ice that's been frozen over and crashing around and moving around. And here's some folks wandering around. And if we take a look at the sun, which we'll go ahead and center right there, and we're going to just track the sun as it goes through the day. So here we are. It's June 21st at the North Pole, and the sun is way up in the sky. Actually, not that far up in the sky. It's only about 23 degrees above the horizon, 23 and a half actually. And the sun simply goes around and around. Let's go ahead and speed this up and get a few days at a time here. Here we go. Look at that. Day after day after day. It's 24 hours of sunlight. Constant daytime. For days and days. And in fact, let's go ahead and skip ahead. It's June 26th now. We're going to jump ahead to July. Okay, here's the end of July. Sun is still up. Here's the end of August. Oh, the sun's finally starting to go down. We're getting a sunset. And so let's go ahead and work our way through early September here. September 2nd, 3rd, 4th, 5th, and so on. And each day, the sun gets a little lower in the sky. Here we are at the 16th of September, 17th. I'll go ahead and let it play now. Here's the 18th of September. Any guesses on when the sun's going to go down? Finally, on here we are at September 21st. And we are right around the fall equinox. And on September 23rd, it looks like, right around this fall equinox, the sun goes down at the North Pole. And it's not going to come up for quite a while. So here's the end of September. Here's the end of October. Trick or treat. Here's the days of November, very dark. And December, end of December. January, day after day after day of just darkness. February, here's March. We're now into early March. And when do you think the sun's going to come back up? Let's scroll ahead here till March 18th. Here's March 19th. March 20th. Any guesses? Yeah, March 21st. So on the spring equinox, the sun finally comes back up and will then be up for the next 6 months. A nice long sunrise, lasts for weeks, and it just goes around and around and around you. You can bump ahead to April, sun's getting a little higher in the sky, May, and back to late June. And so you've got months and months, 6 months of straight daylight at the North Pole. Now, if we want to check out the South Pole, we go down to Antarctica, and we can do the same thing. It's now, we're still in June 21st. It's the summer solstice. Well, at least the summer solstice in the northern hemisphere, because on June 21st in the southern hemisphere, we have constant darkness. We'll go ahead and speed this one up as well. And so day after day after day, the Earth is simply spinning around, and not a whole lot of changes happening there in terms of what's going on. It's just cold. There's no sun to heat the surface. So let's jump ahead from June to July. Here's late August. The sunrise is starting to appear. And as we work our way through August, and we'll just go ahead and scroll slowly through September, we're now the 16th, 17th, 18th of September, 19th of September, and finally the sun is coming up slowly. 21st of September, and we now are starting to see glimpses of the sun right there at the fall equinox. But of course, for them it's not the fall equinox. At the South Pole, this is the spring equinox in late September. So the sun comes up, circles around day after day after day, and as we scroll ahead to October, November, and December, here is December 31st, basically the middle of winter for us in the northern hemisphere, but in the southern hemisphere, the sun is simply circling around and around, and at the South Pole here, you can see that the sun is simply just going around and around in circles. Amazing. What a crazy, crazy place. And then as we move into February, March, the sun's starting to set again. We now have our weeks-long sunset. And as we work our way through March, any guesses on when the sun will finally go down? 15th, 16th, 17th, 18th of March, 19th of March. The sun is approaching the horizon finally. And March 21st, the sun finally disappears behind the horizon. 6 months of darkness is headed our way. Well, at least if you live at the South Pole. There you go. So let's take a quick look at what that looks like in terms of a graph. We've graphed the daylight hours in various places. So here in Oregon, we have a little bit of difference between summer and winter in terms of daytime and nighttime. So on June 21st, for instance, we've got about 15 hours of daylight, and the rest of the 24 hours, which is about, that'd be about 9 hours, a little less than 9 hours, would be darkness. And in the winter, in the winter solstice, we've got about almost 9 hours of daylight, and the rest, about 15 hours, is in darkness. Of course, you can change the latitude that we're looking at here. So if we go up to, say, Alaska, it's going to look a bit more like this, more extreme, long days in the summer, short nights, short days in the winter, long nights. And if we go all the way to the North Pole, here's what we see. Whoa, pretty extreme. Basically, for 6 months, you have 24 hours of daylight, and then on the autumn equinox, boom, you're back into darkness for 6 months. If you move to the South Pole, and we head that direction, South Pole is the exact opposite. Oops, come on. South Pole is the exact opposite. You have 24 hours of darkness and then 24 hours of sunlight for 6 months each. Now here's the interesting part. If you go to the equator, you actually have exactly 12 hours of, I'm going to get right on it, you have exactly 12 hours of daylight all year long. Every single day is exactly 12 and 12. Crazy. Now, if you show the yearly average here, obviously the yearly average at the equator is 12 because every day is 12. But even if you go up to Oregon, somewhere in here, you still see that the yearly average is 12. You get a little bit more daylight in the summer, a little less in the winter, but the average is out. And even if you go to extremely far north places, like the North Pole, you have an average of 12 hours per day. You get it all in 6 months, and it averages out 24 hours for 6 months and 0 hours for 6 months. Averages out to the same amount, 12 hours in each. Now we're going to do one more location here with Sun, Earth, and Moon here, and the location we're going to head to is a little farther around our orbit, our revolution around the Sun. And so we're going to just accelerate time here a little bit. Sun is now sort of behind us, and right about here, right about there is what we're going to look at. Let me get us oriented. So there's the Sun, and there's the Earth right there. And if you look at any location, so for instance, let's take a look at Oregon. Speed this up just a little bit. Turn that line off so it's out of the way. How much time is it in the day and how much time is it in the dark? Well, we've got, it looks like exactly half of the time it's in the day and half of the time Oregon's in the dark. So this is 12 hours of daylight, 12 hours of night, equal amount of night, equinox. This is an equinox. And one easy way to tell is by looking at the North Pole. You can see the North Pole is right on the line between darkness and daylight, and so that is that day when the sun is just beginning to come up at the North Pole again. And it'll be up for the next 6 months, but right there you can see it's right on the line between dark and light. In any location on Earth, whether you're in Alaska or in Oregon, or if you're even way down in Argentina or New Zealand, you're going to get exactly 12 hours of daylight and 12 hours of darkness. One last cool place we'll go and check out is right on the equator. This makes for a unique finale here. And if we go to Quito, Ecuador, named after, of course, the fact that it's on the equator, let's go ahead and watch the sunrise. So we're right here, we're facing east, and we're going to watch the sunrise come up in the east. We're in March right now, and as the sun comes up, it comes straight up off the horizon. Kind of unusual. Right overhead, and then if we cruise around and face west, watch the sun set. Straight down. Crazy stuff. So let me scroll all the way out here, and we'll go ahead and watch watch what this looks like. It'll come up in the east and go down in the west. There's midnight and sunrise. We're going to have exactly a 12-hour day, because on the equator every day is 12 hours. And look at this, right at noon, right about noon, the sun is directly overhead. If you have a bald head, you better put on some sunscreen or a hat. And then the sun goes straight down in the west. You can see why the days are exactly 12 hours long. It's going exactly from east to west, right over the top of our heads. Pretty crazy. All right, folks, hope you enjoyed your tour of the tilt of the Earth and the seasons from space at the poles and here in sunny tropical Ecuador. We'll see you next time.